All right, in this lesson, we're going to look at the addition and the subtraction of rational expressions that have the same denominator. All right, when we look at these two things, we're going to do the same thing as we've done before. We're going to look at just how we would normally add fractions that have the same denominators. For instance, let's say we have 5 over 18 plus 7 over 18. Okay. 5 over 18 plus 7 over 18. Well, what we do in this case is we'd, add the 5 and the 7, right? That's 5 and 7, which is 12. And we keep that same denominator. And then after we're done here, then we would simplify the 12 over the 18. If you notice, they both have a common factor of 6. 6 goes into 12 2 times, and 6 goes into 18 3 times. And so we're going to end up with a fraction 2/3. So if we add 5 over 18 plus 7 over 18, we get 2/3. All right, and once again, what we just did was we added the numerators. So if it was a subtraction problem, we would subtract the numerators. We kept our same denominator, and then we simplified at the end. All right, and so this is what we're going to do when we have rational expressions with variables. So let's look at an example of that. In this example here, we have x squared minus 3x minus 51 over x squared plus 11x plus 24. And we're going to add to that the rational expression 6x plus 11 all over x squared plus 11x plus 24. Again, what we want to do here is we want to add our numerators. So I'm going to write a big fraction here. X squared minus 3x minus 51 plus 6x plus 11. And we're going to keep our same denominator. Okay. When we do start adding these together, we're going to see that we have some like terms. For instance, I have a negative 3x here and a 6x here. We can combine those, and we have a negative 51 here and a positive 11 here. When we combine these like terms, we get the numerator becoming x squared plus a 3x minus 40 all over that same denominator, x squared plus 11x plus 24. Now we've gone from having two rational expressions to having one. And now that we have one single rational expression, we're almost done. The only other thing we have to do is simplify. And so I'm going to simplify my numerator by factoring. Remember, in order to simplify, we factor to see if anything cancels. All right. So my two numbers will be positive 8 and negative 5. And last but not least, the denominator factors into an x plus 8 times an x plus 3. If you notice, the x plus 8's cancel. And so we're going to be left with x minus 5 over x plus 3. All right, and that's my final answer. This is what this sum comes out to be. Let's look at some other examples. All right, in this example, we have these two rational expressions. And if you notice in the denominators, it looks like we may have the same denominator, but we really don't. What we actually have here are opposites. So if we're going to simplify this, we've got to make one of these look like the other one by factoring out the negative. So instead of writing 49 minus x squared, what I'm going to do is I'm going to rewrite this as a negative x squared minus 49. Now I want you to think here. What we said before was that if we have a negative on our denominator or even on our numerator, we can always bring it out front. And so the way I'm going to rewrite this problem is I'm going to keep that first fraction the same. I'm not doing anything to that yet. But with the second fraction, it's going to be plus a negative 2x minus 23 all over x squared minus 49. And again, all I've done was I brought that negative on the outside of my fraction, right? A positive divided by a negative is a negative. Since I have a plus a negative, that's the same thing as subtracting. So I'm just going to rewrite this one time as a subtraction, right? Since I'm adding the opposite, that's subtraction. and I'm subtracting this rational expression here from the first one. Okay? And now that I have my same denominator, I'm ready to start to subtract. Okay? So I'm going to write one single fraction, x squared minus 49, and I'm taking x squared plus 10x minus 16, and I'm subtracting from that 2x minus 23. Now notice that I put that 2x minus 23 in parentheses. The reason why I'm doing that is because I actually have to distribute this negative not only to the 2x, but also to that negative 23. And once I have that done, I'm going to have x squared plus 10x minus 16 minus 2x plus 23 all over x squared minus 49. Now I can see that I have like terms here, and I have a set of like terms in this negative 16 and that plus 23. When I combine those like terms, I get x squared plus 8x plus 7 all over x squared minus 49. Okay. I'm going to factor so I can simplify. So I've done my addition slash subtraction. Our addition became subtraction since we had opposites in our denominators. But this factors into x plus 7 over x plus 1 over x plus 7 times x minus 7. And if you look at that, we have some opposites here. Not opposites, I'm sorry. We have like terms in the x plus 7s. So we're going to cancel those like terms. And our final solution will be x plus 1 over x minus 7. That is our final solution here. Okay. So with opposites, although they don't seem to be the same denominator, we can rewrite opposites as the same denominator. And remember, you have to always keep your negative here, so that you will make sure you're on the right track. All right, let's look at another example. We have 3x squared minus 14x minus 45 over x minus 6 minus a negative 2x squared plus 14x plus 9 all over 6 minus x. Again, we have those opposites in the denominator, right? I'm going to take this denominator here and I'm going to do the opposite of it, right? That'll be a negative x minus 6. Okay, same thing, but it's just written a little differently. Now that I have this negative on the outside, the way I'm going to write this is I'm going to keep the first fraction exactly the same. But instead of having this, well, let's just go ahead and write it. I'm going to bring my negative on the outside. And I'm going to have a negative 2x squared plus 14x plus 9 all over x minus 6. Now, there's one thing that I don't want you to do. This negative right here and this negative right here don't cancel, okay? This negative 2x squared plus 14x is inside this entire fraction on the numerator, right? So if I have a negative, if I wanted to cancel with that negative that I kind of blacked out there, then I have to change this 14 to a negative 14 and this 9 to a negative 9. But I'm not going to do that since this is on the outside. It complicates things. What I will do is I'll notice that I have a subtracting of a negative number here. And so instead of subtracting a negative, what I'm going to do is I'm going to add the positive. And so what I'm going to have here is, this is going to equal, my first fraction stays the same. But since that's subtracting a negative, it's going to be a positive. And I still have this negative 2x squared here. Okay, and remember, this negative only belongs to the 2x squared. It doesn't belong to that 14x, and it doesn't belong to that 9. That's why I couldn't do the above up there. And so now that I have this, I have my same denominator, so I can keep my same denominator. in one fraction and just add my like terms. So I'm going to have plus a negative 2x squared plus 14x plus 9. I'm not worrying about putting the entire polynomial here. I'm not worried about putting this entire polynomial in parentheses because this is a positive. If had that been a negative, I would have put the entire thing in parentheses. But it's not, so it's not really going to matter in this case. All right, now I'm going to combine like terms. We have a couple of pairs of like terms here. We have a 3x squared and a negative 2x squared that we're going to combine. We have a negative 14x and a positive 14x. And last but not least, we have a negative 45 and a positive 9. And so let's go ahead and combine those like terms. 3x squared plus a negative 2x squared is just 1x squared, or just x squared. Negative 14x plus 14x, they cancel. And then negative 45 plus 9 is a negative 36. All over x minus 6. And so once we have this, we are at the point where we have one single fraction. Everything is combined. Now let's factor to see if we can simplify. Well, that's a difference of squares, so I can factor that into x plus 6 times x minus 6. And my denominator is x minus 6. I can write it in parentheses. And if you notice, x minus 6 is canceled. And we're just left with that x plus 6 in the numerator and a 1 in the denominator. But we don't have to write divided by 1, right? It's just divided by 1. So it's just x plus 6. All right, and that is the complete version of our solution for this addition here, or that subtraction that became addition. Okay. This is actually it for what we're going to do right now for this video.